Hi, welcome back to Physics Teacher. This was a question on the Avogadro exam, which is a grade 11 contest for chemistry students from Waterloo University. Give it a try, and I'll be right back with the solution. So in this question, we're trying to produce iron using these two reactions. The question asks how much oxygen is going to be required to produce 100 kilograms of iron. So what we're going to do is we're going to work backwards. Since oxygen gives us carbon monoxide in the first reaction, and then we need that carbon monoxide as a reactant in the second reaction to give us iron, we're going to work backwards. So let's first say, in order to get 100 kilograms of iron, how much carbon monoxide do we need? And this is the equation we're going to use in stoichiometry. It's going to be the number of moles equals the mass divided by the molar mass. So what we're given here is the mass of iron. And what we can get from our periodic table is the molar mass for iron. So if you look up iron on the periodic table, your molar mass, M, for iron is 55.85 grams per mole. And you do get a periodic table on this contest. You do not need to memorize all of these. Alright, well if we know the mass and we know the molar mass, we can figure out how many moles of iron we have. So we'll take 100 kilograms and divide by 55.85 grams per mole. And then make sure you check your units because kilograms will not cancel out with grams. So you can either change kilograms to grams or grams to kilograms, whichever you like. I will leave the kilograms here and I will change these grams to kilograms. So it'll be 0.05585 kilograms per mole. And so now you can see the kilograms cancel and we end up with 1,790.51 moles. I'm giving myself little extra significant digits because we are only partway through the question. Now that we know the number of moles of iron, we can use these coefficients as a ratio to figure out the number of moles of carbon monoxide was required. So what we do is we take 1,790.51 moles, and that's of iron. And we're going to multiply this ratio of 3 moles of carbon monoxide for every 2 moles of iron. And we do that, you notice moles of iron cancels, and you get moles of carbon monoxide, and we end up with 2,685.77 moles of carbon monoxide. So that's the first part of our problem. Now we're going to go to the first reaction. Knowing how many moles of carbon monoxide we have, how many do we need of oxygen? And we're going to use the coefficients again as a ratio to help us convert that. You don't see a coefficient here, but that's just because it's 1. So once again, we'll use this many moles of carbon monoxide and we'll multiply it by 1 mole of oxygen for every 2 moles of carbon monoxide. And when we do that, we will know how many moles of oxygen is required. And it turns out to be 1,342.88 moles of oxygen. Okay, now we're going to go back up to our original equation, where we have the number of moles equals mass divided by molar mass. Now the question is asking for what mass? So it's m, small m, we want to solve for. So let me rearrange that, and we're going to have mass equals the number of moles times the molar mass. But to figure out the mass of oxygen, we're going to need the number of moles of oxygen, which we have, multiplied by the molar mass of oxygen. And that we're going to need to check on our periodic table. Now, oxygen is 16 grams per mole. But since we have two of them in O2, we'll do 16 times 2, which is 32. So we'll take this and we'll do 1,342.88 moles multiplied by 32 grams per mole. Moles will cancel, and we'll end up with their answer in grams, which is 42,970 grams, or converting to kilograms and rounding it, 43 kilograms. So our answer is B.